Hello everyone, so today I'm gonna talk about 1.6, the linear cost model. So recall that that the cost will be equal to the total cost. Total cost in the business, total cost will be equal to fixed cost adding with per item cost, and then per item cost must multiply by X, right? Okay. So we go ahead and apply these information into examples 1.21 below plus so far, right? So the plus sofas manufacture sofa and sell them to retailers. Their recliner armchairs model is very popular. The cost to make this sofa is divided into fixed cost and per item cost. All right. So per item cost sofa is $500. So what does that mean? That means each sofa they made, right? They had to pay $500 for what? For cloth, for wood, for springs, for hardware and labor, right? So if they make more sofa, they have to pay more for this cost. That's the reason why we call it per item cost. All right. What else do we have? We have fixed cost. Okay, fixed cost, which is $3,000. So this cost usually is cost that pay for one-time setup, such as design, cutting paper, cutting cartons, and construction space. So it's mean like you even you don't pay for the you don't make any items, you still have to pay for this cost, because that is fixed cost. Okay. So per A, how much does it cost to manufacture one armchair model? So we can have total cost as fixed cost plus per item cost. Fixed cost in here is 3,000. Maybe I'm gonna label here as fixed cost, which equal to 3,000, and per item cost equal to $500. So total cost will be 3,000 plus 500 times with X, and I mean total cost. Let's write C of X. And in this case, no, actually, I don't want to write the model first. I'm gonna just write just finance time with only one, because we have only one armchair made. So that's gonna be $3,500 total. All right. So what about how much did it cost to manufacture 10 armchair? So in this case, you have total cost, still pay $3,000 at fixed one, And $500 now you have to multiply it by 10 chair, because you make 10 armchairs now. So what is that going to be equal to? 3,000 plus with 5,000, and that's cost going to be $8,000. All right. So the formulas for the total cost, like, instead of one chair, instead of 10 chair, now I have a chair. I keep my that a chair right now. So that will be C of X equal to fixed cost 3,000 plus 500 times with action, right? So again, that's gonna be in the form as I wrote above here. Total cost will be equal to fixed cost plus per diem cost times with X. And sometimes per diem cost called variable cost. Okay, sometimes we call per item cost as variable cost. Okay, the reason was this cost is changing by the item, so we call it variable cost. Okay, use other color and say, okay. So let's move to the next columns. The graph below show all the solution to the cost equation. So you can see it's cost, it is a cost function, right? And in the real life, we just consider from zero item here. So you have items, right? And it is cost. Okay. So I will add this. Time to fix it in the future. See missing costs and items. All right, so the cost will be labeled as C of X, and the items or the demand, say demand in X items, right? Well, actually, I would not say demand, I just say the number of items here. That's good enough. Okay, so now we have questions say how much did it cost to make 2 sofas? So what you do is you will look at the 2 sofas. Okay, so 2 items, right? And from these 2, you're gonna map it to the graph. Right? And from and you see a point there, and from that point you map back to the cost. So you have the cost now is about 4,000, right? According to the graph. Keep in mind that these questions say the graph below show all the solutions. So we just look at by graphically. Okay, look at graphically. We don't have to calculate it by hand, but you can just look at the graph. When you show the bars, you just approximately from the graph over here, right? How much did it cost to make 12 sofas? So look at 12. Similarly, your math is up to the graph, And then from this point, you will have corresponding cost will be about 9,000. Right. So let's put down 9,000 here. Okay. Inversely, if you want to know how many sofa can make for 6,000, then you look at the side of the cost, right? Look for the 6,000. I'm gonna use a color. Okay, 6,000 here. You map it to the graph and looking for the corresponding sofas. So you will have about 6 sofa. Okay. So that's gonna be it for this problems. So I would recommend that you may have to make a dot line to make sure you got the correct one, right? Okay, so now we're gonna move to the next columns. Okay. So these problems is the price for a cup of coffee in the Freudian seat and given the table below. So let's see. Okay, so now, as you see over here, if you look at the left-hand side is the size in ounce. You have 3 sides, right? The first one was 12, the second one was 16, and the last one is 20. So, so the changing, the difference between the first one to the second one is you add them by 4 ounces to get the next size, right? And from the second to third one, you also adding 4 ounces to get the 20 ounce for the last size. Okay, what about the price? Okay, so the first size is $2.35, $2.35. So if you go to the next, one, it's supposed to be adding 30 cents, right? Adding 0.3, right? So then you move to the next level, and I mean, you know that it's supposed to be from 2.65, you're adding 0.4, 40 cents. So honestly, this problem is not really makes sense to me. The reason was usually when you want to buy a bigger size, you should get an offer better price, right? So I would say this is a typo problems and need to change the price better. But anyway, I want to show you in this problem we want to show you the relationship between the relationship between size and the price linear. So so how can you tell from tables? So according to the tables, we can see that the size go up by a constant amount, which is 4 ounces, right? 4 ounces. But the price do not go up by a constant amount. So I'm gonna say, let me come on here. But so then this is not a linear. Okay, not a linear relationship. Okay. So the relationship to be linear need both sides, like need the sign changing by constant amount, right? Go up by 4 ounces, and the price also go up by a constant amount. Similar, like you the number of units you take with the amount of money you pay for the tuition fee. So it's just multiplied by the units, and it's, I mean, the more you take units, the more amount of money you pay constantly adding. All right, so let's we determine from the graph of the point. So let me show you. Show you by decimals. So also is sure. Let me see, I didn't have decimal about that. This one. Open it. Okay. This one is kept different. Okay, so that's fine. I'm gonna show you by same way. What you do is you click on the plus here and make a tables, right? So the X1 in here is actually the size. So I'm gonna put down the size was 12, and the price is 2.35, and I have 16, and then 2.65, and I have 20, then I have 3.05. So let's see what I have over here. So I would like to adjust my range and domain a little bit by click on the graph setting here. I just gonna need it from 0 up to 21 here for the x-axis. 0 to say 21. And for the y-axis, I'm gonna say from 0 maybe -1, that's fine, to 3.5. Okay. So as you see over here, okay, I'm gonna go ahead and grab the line. So see if they can allow me to the line. No. Okay, so what I do is I'm gonna draw a line. This point to this point. Okay. Then I draw another line from this point to this point. Now you can see that these two lines is not clearly this is not a straight line. Like this 3 point, not on the same line, right? According to the graph. So let's come back with the graph. Show on Desmos. And I say it's not a straight line. Yeah. Yeah, according to Desmos, we don't have a straight line. Okay. So now let's make another exercise and see if it's gonna be a linear relationship, right? So this one from 10 to 15, what do you have? Adding 5. From 5 to 20, adding 5, right? So the price changes. You're adding 0.65. And then 2.80 to 3.45. Keep adding with 0.65. So is this the relationship between size and price linear? Think about it and explain how can you tell from tables. Okay. So I would left out this one for you to think about it in 1 minute. You can pause. You can pause and then when you finish, just resume it. Okay. All right. So the answer supposed to be yes, right? Both. The reason is both go up by a constant amount, right? So so I will gonna just save my line by copy this one. And then I put down here. I say size go up by constant amount is 5 ounce and price also go up by a constant amount as 0.65. So this is a relationship, linear relationship. Okay. So we just finished section 1.6. The cost as a linear, right? So according to this section, we can understand that the cost models, you can think as a linear functions with the fixed cost as a y-intercept and the per item cost as a slope. Okay, so I will see you in the next session.